All right, this lesson is on 641, factoring polynomials. So remember that a number is divided by any other factor. The remainder is going to be 0. So we've been doing polynomial division with long division and synthetic division. If we divide the two polynomials and we get a remainder of 0, then it's considered a factor. The remainder theorem states that if a polynomial is divided by x minus a and the value of a is 0, then it is a factor. So there is an example of the remainder theorem in this box that shows you a polynomial that is divided by the factor x minus 3. So when you do synthetic division, so notice that this is x minus 3 is the factor. What I like to tell my students to do is just set that equal to 0 and then solve it for x. You add 3 to both sides. So x equals 3. So then you set up your synthetic division and you go through synthetic division and the remainder is 7. So this would not be considered a factor of that polynomial. So example 1, use synthetic division to divide to find out what is p of negative 3. So we set up our synthetic division box. Polynomial is x cubed, x squared, x, and constant as your placeholders. Then you put your coefficients in, 1, 3. Now there isn't an x term, so you just put the number 0 and our constant of 4. So that is our polynomial. And then we're dividing by essentially x plus 3. So I'm going to set that equal to 0. And then I'm going to solve it. So I'm going to subtract 3 from both sides. We get x to be negative 3. So negative 3 goes outside the box. Now we're ready to do our synthetic division. So we bring down the 1, and then we multiply 1 times negative 3, which is negative 3. We add the column and get 0. Then we multiply 0 times negative 3, which is 0. Add the column, then multiply 0 times negative 3, which is 0, and then add the column. So notice that this remainder is not 0. So x plus 3 would not be a factor. But it does tell us what the value of p of negative 3 is. So if you were to try and find an ordered pair, the ordered pair would be on the polynomial negative 3, 4. But it's asking us to evaluate what is p of negative 3. So you just choose your remainder as what your value of p of negative 3 is. Here is our factor theorem. So again, if you have a polynomial and you divide by a binomial of x minus a, and that remainder is 0, then it is a factor. So again, we will use synthetic division, and if the remainder is 0, then that binomial is a factor of the polynomial. So here's our polynomial. We set up our synthetic division. Our placeholders of x squared, x, and constant. Then we put our coefficients in, 1, negative 3, and 1. Now here is our factor that we're trying to test. So we say x plus 1 equals 0, and then we solve it for x, so we subtract 1 from both sides, and we get x to be negative 1. So negative 1 goes outside the box. Now we start our synthetic division. We bring down the 1, we multiply 1 times negative 1, which is negative 1. Then we add the column, negative 4. Then we multiply -4 times -1, which is +4, and then add the column. There is a remainder here, and it's not 0. So what that tells us is x plus 1 is not a factor of the polynomial. Okay. Next example, we have a polynomial, and we want to find all of the roots. Looks like we're missing example number 3, so I will come back to that.